Classic PDE tutorial. Resonance frequencies of a room. This example calculates resonance frequencies of an empty room, using the Helmholtz equation for the time harmonic pressure field. The resulting eigenmodes can be compared to, and validated against the analytical solution for the resonance frequencies of a boxed enclosure. The tutorial can also be run by selecting Model Examples and Tutorials, Classic PDE, Resonance Frequencies of a Room, from the File menu, and followed along with the step-by-step instructions in the user's guide. To start a new model, click the New Model toolbar button, or select New Model from the File menu. Select the 3D radio button. Both the Poisson and custom equation physics modes are suitable starting points for this model example. Select the custom equation physics mode from the Select Physics drop-down menu. Enter P into the Dependent Variable Names edit field. Press OK to finish the physics mode selection. Geometry mode. Press the Create Cube Block toolbar button. Enter 4 into the X max edit field. Enter 3 into the Y max edit field. Enter 2.6 into the Z max edit field. Press OK to finish and close the dialog box. Grid mode. Switch to grid mode by clicking on the corresponding mode toolbar button. Enter 0.5 into the grid size edit field. Press the Generate button to call the grid generation algorithm. Equation mode. Switch to equation mode by clicking on the corresponding mode toolbar button. Press the Edit button. For this eigenmode analysis, the right-hand side of the Helmholtz equation is not involved, and is therefore set to 0. Enter the expression into the equation for P edit field. Press OK to finish and close the dialog box. Press OK to finish the equation and subdomain settings specification. Boundary mode. Switch to boundary mode by clicking on the corresponding mode toolbar button. Homogeneous Newman boundary conditions are used for all boundaries, to represent solid and impermeable walls. Select all boundaries in the Boundaries list box. Select the Newman, GP radio button. Press OK to finish the boundary condition specification. Solve mode. Switch to solve mode by clicking on the corresponding mode toolbar button. Press the Settings toolbar button. Select the eigenvalue solver in the Solver Settings dialog box, and increase the number of eigenmodes to compute to 9. Press the Solve button. Post-processing mode. Open the Post-processing settings dialog box, and plot and visualize some eigenmodes to compare them. One can see how the lower modes resonate in a single direction, and increase in complexity and frequency as the number of resonance modes are added. Press the Plot Options toolbar button. Clear the Enable/Disable Surface Plot checkbox. Select the Enable/Disable ISO Surface Plot checkbox. Press Apply to plot and visualize the selected post-processing options. Select 0.609274 0.12423 Hz from the Available Solutions Eigenvalues Frequencies drop-down menu. Press Apply to plot and visualize the selected post-processing options. Select 1.07455 0.1649881 Hz from the Available Solutions Eigenvalues Frequencies drop-down menu. Press OK to plot and visualize the selected post-processing options. Compare the frequency of the computed modes to the analytical results, assuming a speed of sound c equals to 1 so that f0, 0.125, and so on. The tutorial is now complete, and the model can be saved as a binary file, exported as a MATLAB M script file, or a GUI playback file.